Welcome to another video. In today's video we are going to solve count number of rectangles containing each point. In this problem we will be given a vector of rectangles which are represented by height and width of that particular rectangle, and we need to determine for each point how many rectangles contain each point. Let's say we are given these rectangles which are represented by width and height of the rectangle. If we consider this first vector, so these are all the rectangles as mentioned in the problem statement. 1 represents the width of the rectangle and 2 represents the height of the rectangle. Similarly, for the second rectangle, 2 represents the width of the rectangle and 3 represents the height of this rectangle. And for the third rectangle, 2 represents the width of the rectangle and 5 represents the height of the rectangle. So now we know about the rectangles. Now there are some points which are present. For the point 2, 1, which is represented here, we need to determine how many rectangles contain this point. So from the image it is clear that second rectangle contains this point and the third rectangle also contains this particular point. So the count for this particular point is 2. And similarly for this point 1, 4, if you observe the image, only third rectangle contains this particular point. So the count for this particular point is 1. So we need to determine how many rectangles contain a particular point, and we need to return in a vector. So that is what we need to do. So let's go through some examples to understand how we can implement this solution. Let's understand the basics of how we can determine whether a particular point belongs to a rectangle or not. So if you want to implement a brute force approach solution for this particular problem, let's consider some point x, y. And if you want to determine if this point belongs to a particular rectangle which is represented by length and height of the rectangle. So if you want to determine this, then what is the condition? So as mentioned in the problem statement, if you are considering a rectangle, each rectangle, this bottom left corner lies at 0, 0. So if this is the case, and then if then this point will be L, H, because this is the length of the rectangle and this will be the height of the rectangle. And if we consider some point, let's say x, y, so this point, let's say it has coordinates of x, y. We need to determine whether this point lies inside this rectangle or not. So for that, condition is very simple here. So our x coordinate should lie from 0 to h. So that is our x, sorry, that is not the x. If you consider this x coordinate, that should lie from 0 to length. Our x coordinate should lie between 0 to length, and our y coordinate should lie in between 0 to h. So if these two conditions are satisfied, then this x, y point will lie inside this rectangle. So if this is the condition gets satisfied, then we can say that this particular point belongs to this rectangle. So we can do this for each and every rectangle. If you want to implement a brute force solution, what we can do is for each point we will go through each and every rectangle and check this particular condition. If this condition is satisfied, if these two conditions are satisfied, then we know that this particular point belongs to this particular rectangle, and we can increment the count for that particular point. This is the brute force way of doing it. But since we have so many rectangles are present, and in the problem statement they have mentioned that, I think in the constraint they have mentioned, okay, here, so h, that is height, will vary from 1 to 100. So that means we can easily iterate over the height. So from the constraint we know that h value varies from 1 to 100. So using this condition, we are sure that we can easily iterate over all the heights, but when it comes to width they haven't mentioned any limits. So if we use a brute force approach, it is we are sure that we are going to get a time limit error. So in order to optimize this search, what we can do is, let's consider one example so that this approach becomes very clear. Let's say we have a point like this. We know that for this particular height we have a rectangle. This point belongs to this rectangle. Let's say we have one more rectangle that is represented by green with the same height but with a different width. So this point belongs to this rectangle as well. Let's say we have one more rectangle, so with the same height but with a larger width. So this particular point belongs to all three rectangles here, because all three rectangles will contain this particular point. So what we can do is we can map each height, so each height into widths. From the rectangles we should create this mapping for particular height, what are all the widths which are present. And afterwards, once we have that width, we should arrange them in increasing order. So let's say let's consider this as an example. Let's say this is 0, 0, 0, and this is 0, 2. And let's say our first rectangle is height of 2 and width of 3, and our second rectangle is height of 2 and width of 5, and our third rectangle is height of 2 and width of 7. So these are all the height and widths of our rectangle. If this is the case, and let's say if we consider this point 1, 1, so if this is the point, this particular point belongs to all these rectangles. So what we can do is, let's say if we have a map from height to, if we have 3, 5 and 7, then we can check, then we can use binary search in this range to determine what is the first value which is greater than or equal to given width. So if you find out that, then all the values which lie to this side, that is total length minus that index which satisfy this condition. So then these many elements will satisfy this condition, and all those rectangles will contain this particular point. That is why I explained this particular example. So by keeping this approach, we can easily reduce the search area, and we don't have to go through each and every rectangle. So let's implement the same solution that we have discussed here. So this technique will become clear once we implement the solution. Let's implement the same solution that we have discussed here. The first step that we have discussed here is creating a mapping from height to particular widths. So let's create a map from, let's say, integer to vector of ints, and I'm going to call it as height to widths. So this is the map that we are going to use in order to map all the heights to particular widths. So now, okay, instead of C++, I have chosen, let's reset. Okay, let's implement the same solution that we have discussed here. The first step is creating an ordered map from height to widths. Let's start declaring a map here. Unordered, let's call it as map from integer to vector of int. height to width, and after that we can go through all the points. Int I equals to 0, I less than points dot size I plus plus. So what is the height here? Height will be the first element which is present in that points vector, points of I of 0, and width will be equal to points of I, 1. So now we have height and width, we just have to add it to our map. Height to width dot insert. What we can do is add to width of h dot pushback w. So now we have inserted these points, and afterwards what we should do is we should iterate over this map and just sort it. Let's say we declare an iterator. And this iterator we can initialize it to the beginning of this map, and we can go through all the entries of that particular map in order to sort, while iterator not equal to height to width dot end. Then what we can do is sort of iterator second. This will give us the vector, and we need to pass beginning and ending of that particular vector to be sorted. So what we are doing here is I'm just creating this mapping actually. Now we already have for a particular height I have all the widths from this first for loop, but here what I'm doing is I'm creating this in a sorted order so that searching for widths satisfying a particular condition becomes easy. And after that what we can do is for int I equals to 0, I less than points dot size I plus plus. So we should declare one more vector of int named count, which will be of point size. So this is where we are going to store counts for each point. So now for each point we can say x equal to points of I comma 0 and y equals to points of I comma 1. Now what we will do is we are going to iterate over for int h equals to 0, h less than or equal to 100, h plus plus. So for this h, let's say if x satisfies this condition, that is x is greater than or equal to 0 and x is less than or equal to, so now we need to check for that y condition. Y is greater than or equal to 0 and y is less than or equal to h, and we need to check whether that height is present or not. Height to width dot find of that particular height, that is y. If that is not equal to height to width dot end, then we need to increment the count of y will be plus equal to get greater than equal to count of what we are going to pass here is all the widths, that is height to widths of this particular h. So instead of y we need to consider this h. This h, and our width we need to pass, that is x. So we just have to implement this particular function, but apart from that nothing is needed. So after that we can simply return count. So only thing pending here is we need to implement this particular function. So it returns an integer get greater than equal to greater than or equal to count of what we are going to get here is, first thing is we are going to get an array, and then we are going to get a value. So first thing that I'm going to do is I'm going to get the total length of the array given to this function. So that will be array.size, and then I'm going to use binary search technique. In left will be 0 and our right boundary will be total length minus 1. And while we need to determine how many elements in the array, this array is already sorted. We have already sorted this array. So in the sorted array we need to determine how many values which are present are greater than or equal to this particular value. So initially I'm going to, let's say I'm just going to maintain an index of that particular. I just want to find the first value which is greater than or equal to this particular value in the array. So while left is less than or equal to right, what I'm going to do is I'm going to compute the mid, that is left plus right minus left, divided by 2. After that I'm going to check whether if ARR of mid is greater than or equal to value. If middle satisfies this condition, then our middle is a possible answer, and there can be better answers to the left of that middle. So I'm going to bring left boundary to mid minus 1. Otherwise there is no point in searching to the right. I have to, if middle itself is less than the right, then I need to search in the left range. So I will bring my right boundary to mid minus 1. So I have to bring my left mid plus 1. Here I should bring my right boundary. So middle itself is greater than or equal to, middle element itself is greater than or equal to value, then that means there may be better answers to the left side of the middle. So I have bring the right boundary to mid minus 1 here. Otherwise I will bring the left boundary to mid plus 1. So after this I will check if answer is -1. If this is the case, then we didn't find any element which is greater than or equal to value. In that case we should return 0. Otherwise we have to return total length minus answer. So let's submit this solution and check whether it passes the initial test cases or not. Okay, we are getting a time limit error here. Let's see what we are doing it in a wrong manner. Okay, here in the while loop we are not incrementing that iterator. Let's run this solution again and check whether it passes the initial test cases or not. Okay, the mistake that we made here was we are not just iterating over all the rectangles. So this should be, we made a mistake here, rectangles dot size. So we, instead of iterating over the rectangles, we just iterated over these points. We have to iterate over rectangles in order to create that map. So let's run this solution and check whether it passes the initial test cases or not. Yes, the solution is passing the initial test cases. Let's submit this solution and check whether it passes all the test cases or not. Yes, the solution is passing all the test cases. So the approach is simple here. First we created, by going through all the rectangles, we created a map from height to all the widths, and after that we sorted those mappings. So similarly what I have explained here, we sorted all these widths for a particular height, and after that we started going through points, and if a particular point height, if a particular y lies within that height range, then we will start binary search to get how many widths that are greater than or equal to given width, that is x is we are going to check this particular condition. So after that we are going to add that count to our points count. So I hope you like this video. If you are interested in learning more about other data structures and algorithm related problems, please check out other videos from my channel. Thanks for watching this video.